In this problem, we need to show that the given trigonometric equation holds true. So we will start from the left hand side of a given problem. So here we will rewrite the given equation as, so from the left hand side we will first write cosine squared b. Then we will have cosine squared a minus b minus 2 times cosine of angle a minus b multiplied to cosine of angle A times cosine of angle B, which this will be equals to cosine squared B. So from the second and the third term, we're going to take cosine of A minus B as the common factor. So this will now get multiplied to, so we are left with cosine of A minus B minus 2 times cosine of angle A times cosine of angle B. Furthermore, we can expand cosine of angle A minus B. So here we know for a fact that whenever we have cosine of angle A minus B, that this can be expanded to get cosine of angle A times cosine of angle B plus sine of angle A multiplied to sine of angle B. So this gives us cosine squared B plus, we're not going to expand it, we are going to keep it aside. So we'll have cosine of A minus B, but we're going to use this expression to expand cosine of A minus B within the parentheses. We're going to get cosine of angle A times cosine of angle B plus sine of angle A times sine of angle B minus negative 2 times cosine of angle A times cosine of angle B. This is going to give us cosine squared B plus cosine of angle A minus B. So now inside the parentheses we have sine A plus sine A times sine B, and we can combine cosine A cosine B with negative 2 cosine A cosine B to get negative times cosine A times cosine B. Fine. So within the parentheses, what we'll do, we will take negative as the common factor, and we'll have cosine of A minus B multiplied to, within the parentheses, we're going to get cosine of A times cosine of B minus sine of A times sine of angle B. Now, inside the parentheses, we have cosine A, cosine B. Now, there's a negative sign here. In our formula, we specified that whenever we have cosine of A minus B, we have a positive sign here. That means the two terms will get added. Meaning, we have a new formula. So, if we have cosine of A plus B, then in that case, this plus will change to negative sign. So, that means in our case, cosine A cosine B minus sine A sine B can be replaced with cosine of A plus B. So, let's do that. So, our expression is now going to become cosine squared B minus cosine of A minus B multiplied to, so this entire expression now becomes cosine of A plus B. Now there is a reason why we're writing in this fashion, because we have another identity which states that if we have cosine of A plus B multiplied to cosine of A minus B, then this is nothing but cosine squared A minus sine squared B. So that means we can replace this entire expression with cosine squared A minus sine squared B. So that means we are now going to get cosine squared B minus, so we have cosine squared A minus sine squared B. So we will further simplify this. Let's open the parentheses. We're going to get cosine squared B minus cosine squared A plus sine squared B. Now we can combine cosine squared B and sine squared B. That because that's a very standard identity. So this standard identity has got a value equals to 1. So 1 minus cosine squared A, and 1 minus cosine squared A, that's nothing but sine squared A. And this is what we are asked to show. This is the expression that is on the right hand side. So hence we have successfully showed that the given trigonometric equation is true.